You know, it's easy to think of our planet as this permanent, stable rock, but it's really on an epic journey through space and time. It's constantly being shaped by forces that are almost too vast to even imagine. So today, let's trace that journey all the way from the daily cosmic weather report to Earth's ultimate fiery finale. Let's get into it.
We see change all around us, right? Seasons, weather, the tides. But what about the really big picture? What cosmic clock is ticking away for our world? And what is its final chapter actually going to look like? That's the big question we're diving into here.
Okay, first up, let's take a look at our immediate neighborhood. And I'll tell you, it's not always quiet out there. Earth is constantly navigating what's basically a shooting gallery of cosmic hazards, from our own sun's violent temper tantrums to rogue space rocks. So, the two main things we're constantly keeping an eye on are solar storms and near-Earth objects, or NEOs for short. One is a threat from the very star that gives us life, and the other is a constant reminder that we share our orbit with millions of other objects.
We actually measure the sun's fury on a scale, kind of like earthquakes. A, B, and C-class flares are pretty minor, but the scale is logarithmic, so it jumps fast. M-class flares are 10 times stronger than C-class, and then you have the X-class flares. They're the real monsters, another 10 times stronger than M-class. Just to give you an idea, the most powerful flare ever recorded, back in 2003, was so intense it was literally off the charts. It just completely overwhelmed all of our sensors.
And it's not just the flares. The sun can also hurl a CME, a coronal mass ejection, our way. Seriously, think of it like a billion-ton cannonball of solar plasma and magnetism. If one of these hits Earth just right, yeah, it can create spectacular auroras, but it can also wreak absolute havoc on our power grids and satellites.
So what about those space rocks? Well, the good news is we're not flying blind. Agencies like NASA's Center for Near-Earth Object Studies are basically our planetary defense system. They are constantly scanning the skies, tracking any object that might get a little too close for comfort.
Okay, let's zoom out. Let's pull way back from the daily dangers and look at the slower, more profound changes. These are the forces that operate not over days, but over millions and billions of years, fundamentally reshaping our world in a slow cosmic dance. And this slow transformation all starts with the moon. You see, its gravity doesn't pull on our planet evenly. The side of Earth facing the moon gets pulled the hardest, while the far side gets pulled the least. This difference in force actually stretches our entire planet. Now, this stretching effect is most obvious in our oceans, right? It creates two high tides or tidal bulges on opposite sides of the planet. But here's the crucial part. Earth spins faster than the moon orbits us, and because of that, our rotation literally drags those watery bulges a little bit ahead of the moon so they aren't perfectly aligned.
And this tiny misalignment has a huge consequence. That tidal bulge that's slightly ahead has its own mass, its own gravity, and it pulls the moon forward in its orbit, giving it a tiny little energy boost. This boost causes the moon to spiral away from us at a rate of 3.8 centimeters, that's about 1.5 inches, every single year.
Over geologic time, these small changes add up to something massive. I mean, look back 70 million years ago, a day on Earth was half an hour shorter. And looking forward, this slow dance just keeps going. Continents will drift and form a new supercontinent, and eventually, in billions of years, the moon will be so far away that it can't stabilize Earth's tilt anymore, which could plunge our climate into absolute chaos.
Now we move to the ultimate timescale, because no matter what happens on Earth with its tides or its continents, its final fate, well, that's sealed by the life cycle of our star, the sun.
You have to remember, the sun is a giant fusion reactor, and like any aging star, it's getting hotter. It's actually increasing its brightness by about 1% every 110 million years. So, in 1 billion years, it'll be 10% brighter than it is today. And that extra energy is going to have some dramatic consequences for us.
This increasing heat will trigger a slow, methodical end for all life here. First, the higher temperatures will pull so much CO2 out of the atmosphere that most plants just can't survive. Then, the oceans themselves will begin to boil away, creating a moist greenhouse. And finally, the planet will enter a runaway greenhouse effect, becoming a scorched, molten world that's even hotter than Venus is today.
And the final curtain call? In about 7.5 billion years, the sun's going to run out of its core fuel and swell up into a red giant. Its outer layers will expand so far that they will almost certainly engulf Mercury, Venus, and our own planet, wiping the slate of our inner solar system completely clean.
So far, we've talked about things that are pretty predictable, right? Processes that are already in motion. But the universe is also full of wildcards. We're talking about events that are incredibly rare, but if they happened, it would be absolutely catastrophic. Welcome to the Cosmic Lottery. This is the kind of stuff that keeps astronomers up at night. A civilization-ending asteroid impact, a nearby star going supernova and just blasting us with radiation, shredding our ozone layer. Or maybe, the most terrifying thought of all, a rogue star just wandering through our solar system and gravitationally flinging Earth out into the cold, empty darkness of interstellar space.
Now, while the odds of a star encounter are ridiculously low, the universe has even more extreme things out there: black holes. The chance of hitting one is pretty much zero, but they represent the ultimate expression of gravity. And to understand their power, we need to talk about a concept called the Schwarzschild radius. Think of it as the tipping point, the point of no return for matter and gravity.
To put this into perspective, if you wanted to turn our entire planet into a black hole, you would have to compress everything, every mountain, every ocean, all 6,371 kilometers of Earth's radius, and crush it all down to the size of a single centimeter. The density required is, well, it's truly mind-boggling.
So, after this whole tour of cosmic hazards, slow transformations, and ultimate endings, we're left with this question. We exist in this incredibly brief, stable, habitable moment in our planet's unbelievably long and violent story. So knowing the full journey, from its turbulent beginnings to its fiery end, what does that make our time here, right now? It certainly puts our own lives into a whole new cosmic perspective, doesn't it?